Okay, so let's take a look at another example. So here again, we're going to calculate an integral, double integral in polar coordinates. However, this integral is set up slightly differently from the previous example. In this integral, the integral is already set up in rectangular coordinates, like this, with the limits of integration, and we have to understand the region of integration first, and then describe it in polar coordinates. So let's try to do that. Right. So here we have x going between -1 and 1. Right. So let's write out. So x goes between -1 and 1, and then these are the limits for y, right? Because that's how the variables go. So y goes between 0 and square root of 1 minus x squared. Okay, so let's try to take a look at this region in the plane, right? So again, x is going between -1 and 1. So say here and here, the bottom boundary for y is equal to 0. So y equals 0 is just the x-axis. And what about y equals square root of 1 minus x squared? Right, so if you rewrite this equation, right, so you square both sides, you get y squared, and then you add the x squared over. It'll look like x squared plus y squared equals 1, but because this is the positive square root, this is just the top half. And so this curve is the top half of a circle of radius 1. Okay, so now if we shade in the region here, my region R is the upper half disk of radius 1. And so if I want to describe this, right, so here theta only goes between 0 and pi because it's the upper half, and then R, the radius, goes between 0 and 1, right? So theta equals 0, 0 to pi goes like this, and then the radius starts from the origin and goes out to the circle of radius 1, so R goes between 0 and 1. Okay, so so that's going to be our polar region. And so now we're ready to convert the integral, right? So again, we have the change of coordinates, x equals r cosine theta, and also x squared plus y squared equals r squared. So now we set up the integral. So theta is on the outside, theta goes between 0 and pi, r is on the inside, r goes between 0 and 1, and then now we have to plug in the change of coordinates, right? So x is r cosine theta, so we have r cosine theta squared, and then x squared plus y squared is r squared, but that itself is being squared here. And then also we have dA is equal to r dr d theta, or maybe I should say this dy dx is r dr d theta, so r dr d theta. Okay, so that's the whole integral. So now we have to calculate this. Right, so let's simplify it first, right? So how many r's do we have? So we have r squared, and then r squared squared. So there's 4 r's here, there's 2 r's here, and then there's another r here. So in total there's 7 r's. So that's r to the 7th. And then this cosine is being squared, so we have cosine squared theta dr d theta. Right, I've already included this r with the other r's, so we have r to the 7th there. Okay, so now we're ready to integrate. So r first. So the antiderivative of r to the 7th is r to the 8th over 8. And I need to evaluate from 0 to 1. Okay, so if I plug in 1, I get 1/8. And if I plug in 0, this whole thing is just 0. So that cancels out. So I'm not going to write that. So the whole integral is now just 1/8 cosine squared theta. And okay, so here a helpful reminder: when you encounter integrals with cosine squared or sine squared, we can use the double angle formula. So we have cosine squared in this case. So we use this formula, and so we have the integral from 0 to pi 1/8 times 1/2. Again, what do we have? It's 1 plus cosine 2 theta. D theta. Okay, so now we calculate this integral. So 1/8 times 1/2 is 1 over 16. And then the antiderivative of 1 is so actually let me pull the 1 over 16 out of the integral because it's just a constant multiple, right? And then okay, so now I have to take the antiderivative. The antiderivative of 1 is just the variable theta, and the antiderivative of cosine is sine. But I also have this 2 that comes out as 1/2. Okay, so that's the antiderivative, and this is going from 0 to pi. Okay, so now I have to plug in the numbers, right? So what do I have? 1 over 16. Hopefully I have enough space. I'm plugging in pi, so you get pi plus 1/2 sine of 2 pi, and then minus 0 plus 1/2 sine of 0. That should be 0. Okay, let me not try to squeeze in here so you can't see it. Okay, so then minus, I'm plugging in 0, right? So 0 goes in for theta, so that's 0, and then plus 1/2 sine of 0. Okay, so we have that, and luckily most of these cancel out, right? So sine of 2 pi is 0, and then this is 0, and sine of 0 is also 0, so both of these are also 0, and so I'm left with just 1/16 pi. So this is equal to pi over 16, and if we want to write the answer as a decimal, it comes out to 0.1963. Okay, so so this is example 2.